My name is Daniel Kwan and this is Bishop Montgomery High School Math Tutoring Club. We're located in Torrance Boulevard right next to Redondo Beach. Today we're going to talk about the second derivative test. And if you're curious about the first derivative test, you can go into the studio and try to find the video for the first derivative. I have it. So the second derivative test. Through the second derivative test, you can find the concavity of that graph and the point of inflection also. So what is concavity? Concavity is if the graph is concave up or concave down. So if the shape looks like this, concave up. If shape looks like this, concave down. And also the point of inflection is when this two concavity changes right here. Sorry for my face. There we go, right here. And so now we have to solve this through the equation. That's why there's a thing called second derivative test. So second derivative test. So if the question asks which point is the point of inflection, let's go. So if I'll just set any weird graph. Let's see. Oh, I'll just use the same graph, the same function as the first derivative test. So x squared, if I remember correctly, minus 3x plus 2, if I remember correctly. So we chose this, right? Oh, actually, I'll change this to x to the third and x squared to it's easier for you guys to understand. So if I do this, because it's second derivative test, we have to differentiate this function twice. Second twice. So f prime will equal to 3x squared minus 6x and natural number 0. And if I differentiate this again, y double prime equals to 6x minus 6. As you can see, we got this function, right? And now, similar to the first derivative test, you have to set this equal to each other to find the point of inflection. So 6x, and now because here in calculus I trust you guys, x equals to 1. So now your job is to again make that line graph and put this number in the middle, 1. And then again, as you go to the right side, which is positive, you plug in the number bigger than 1, and as you go to the left side, you plug in the number less than 1. So I'll start from the right. What's number bigger than 1? I'll just go with 10 again. 10, so it will be 60, because 6 times 10 minus 6 equals to 54. So it is positive. And for this one, I'll just literally plug in 0. So 6 times 0 minus 6 will be negative 6, so that is minus. So, as you can see, we're figuring out that at the point of inflection 1, because at the point 1, the value we have solved, the sign changes to negative to positive, we have proved that it is an actual point of inflection. Because I will just draw a random graph. If this is 1, before 1, it was, like I said, negative, concave down. So it'll be concave down like that. This is random graph, so I'm just showing you what's concave up and down. So, and after 1, concave up, right? So it'll be concave up like that. So as you can see, right here, I will draw a line. Don't worry, it's not an asymptote, I'm just drawing a line. So right here, at 1, x equals 1, until x equals 1, it was concave down. As you can see, it's down. And after 1, concave up. So negative and positive. This is negative, this is positive. And to prove that one is a point of inflection, or POI, you have to make sure the sign changes between 1. So right now, sign changes to negative to positive. If it will still work if it's positive to negative, because its sign still changes. So in the second derivative test, what you have to do is, with the function, you have to find the first derivative and then the second derivative, because it's second derivative test, which is y double prime. And then set the value equal to 0 and solve for x. So the answer was 1. and then make the line graph like this and plug in 1 and see the value. Put the greater number at the right side, less number at the left side, and after you plug in, see if the sign changes. If it does not, that means it is not a point of inflection. If it does, it's a point of inflection, and you can graph yourself which is concave up and which is concave down. So thank you for watching, and I hope this video was helpful.